In this video, we are going to look at the cooling capacity, electrical consumption, working pressures, and the capillary tube of the 1/6 HP compressor that uses R134a refrigerant gas. 1. The cooling capacity of a compressor mainly depends on the compressor's efficiency and the temperature required in the evaporator. 2. The cooling capacity of a real 1/6 HP compressor varies significantly between models. It can be around 450 BTU per hour, 113 kilocalories per hour, when operating at a temperature of -20 degrees Celsius -4 degrees Fahrenheit. 3. However, if the temperature is -10 degrees Celsius 14 degrees Fahrenheit, or slightly lower, the cooling capacity is around 650 BTU per hour, 164 kilocalories per hour. 4. Now, regarding the regular power consumption of the 1/6 HP compressor, it essentially depends on the supply voltage. For a compressor running on 120 V, the current draw will be approximately 1.5 amps. Whereas for one running on 220 V, the regular consumption will be around 0.75 amps. 5. The working pressures of a compressor that uses R134a can be checked using our simulator. First, we will set a condensing temperature of 45 degrees Celsius 113 degrees Fahrenheit, a superheat of 5 degrees Celsius, a variation of 9 degrees Fahrenheit at the evaporator outlet, and a subcooling of 5 degrees Celsius, a variation of 9 degrees Fahrenheit at the condenser outlet. Remember that the link to our simulator is available in the video description. 6. If we select an evaporation temperature of -10 degrees Celsius 14 degrees Fahrenheit and consider an altitude of 500 meters above sea level, we will get the following pressure values. 7. Now, if we choose an evaporation temperature of -20 degrees Celsius -4 degrees Fahrenheit for the same altitude of 500 meters, the pressure values will be as follows. 8. Next, let's use our simulator to find the appropriate capillary tube size. Let's start with the capillary tube for an evaporation temperature of -10 degrees Celsius 14 degrees Fahrenheit, which is typical for refrigerators. Keep in mind that in this case, the cooling capacity of the compressor is about 650 BTU per hour, 164 kilocalories per hour. On screen, we can see the approximate capillary tube dimensions provided by our simulator. 9. Now let's do the same for an evaporation temperature of -20 degrees Celsius -4 degrees Fahrenheit, where the cooling capacity is about 450 BTU per hour, 113 kilocalories per hour. On screen, we can see the approximate capillary tube dimensions provided by our simulator. Remember that the link to our simulator is available in the video description.